Okay, this is section 3.2, number 11. You're supposed to graph the equations, and remember we did this in Algebra 1, we reviewed it in geometry and several different lessons, and especially there at the end we did. But let's go through this. If we're going to graph this, and it says you may wish to verify on basically a graphing calculator is what we would say. Here's what I would do here. First of all, you got two choices. And I'll talk about both of them. That way you can kind of decide what you want to do. Method one of doing this would be to put it in y equal mx plus b form. That is slope-intercept form. And we put things in slope-intercept form. What we do is we solve for y. And so then I'll kind of just roughly sketch it over here. It's going to be hard to do a really good graph here because of just the limitations that this app has. Okay. Okay, so if I took 3x minus 2y plus 18 is equal to 0, what I'm going to do, let me just go ahead and move the 3x to the other side. I'll subtract 3x from both sides, and I'm also going to go ahead and subtract the 18. I'm going to move all the terms to the other side except for the y term since I'm solving for y. That would cancel out, that would cancel out. I would have negative 2y is equal to negative 3x minus 18. And now if I want to get y by itself, I would divide everything by negative 2. Alright, that cancels out, and that leaves me with y equal, and negative over negative is a positive 3/2 x plus 9. A minus 9 would be a plus 9. 18 divided by 2 would be 9, and there's two negatives. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say it's up here. Now, my slope, that's my y-intercept, that's what I just graphed, right? On my y-axis, let me color it in red, we have a y-intercept of 9. Remember, y equal mx plus b. The b, the number on the end, they call it b, but it's your y-intercept. And then your slope is your number in front of your x. And if the slope is 3/2, that means rise 3, positive 3. That means go up 3. And run 2, that means go right 2. Well, now the problem is if I go up, do you see how I'm at the edge of my graph? I even had to extend it just to get that 9 on there. So here's what I could do. If the slope is 3/2, isn't 3/2 equal to a negative 3 divided by a negative 2? Because a negative over a negative is a positive. If you ever get stuck on the edge of your graph like this is something you can do. You just think of another value that is equivalent to the first value, and a negative divided by a negative is a positive. So what I could do here is say, well, let's rise negative 3. That means go down 3. Okay, and then run negative 2 means go left 2. So I'm going to go down 3 and then left 2. And I could do it again if I wanted to. Down 3, left 2. Okay, so the points I'm going to connect are these right here. And there would be a sketch. So you can take a slope of 3/2 and say that's equal to negative 3 divided by negative 2 and count that off so you can actually not have to go off your graph. And that's what I would recommend doing there for one way of doing it. Now I'll go to another slide for another way of doing this problem. So you could put it in slope-intercept form, which is that y equal mx plus b. That's what I just did here. There is another way you could do it. Oh great. Well, I have to keep going. 3x minus 2y, what was it? I forgot. Plus 18 is 0. Now, another way you could graph this pretty easily is it almost looks like it's in standard form, doesn't it? Remember, standard form is when you have the x and the y on one side and the constant term on the other side. Ignore that slash mark. That just happened because my hand hit the screen. What I could do is let's put it in that form. And all I have to do to put it in that form is subtract 18 from both sides. And now I have 3x minus 2y equal negative 18. Well, do you remember that in the last, I think it was in the last lesson, one of the things they had us do was, and I spoke about it on the video, and I probably did in class too, is when we have standard form, it's kind of easy to graph from that form if you find your x-intercept and your y-intercept, and that's easy to do because in the x-intercept, y is 0, and we could plug that in, and in the y-intercept, x is 0, and we could plug x equals 0 in, and we could find those 2 points really easily and graph and be on our way and, it has some really important points on our graph. So that's what I'm going to do. First, I'm going to find the x-intercept. I'm going to plug in y as 0. So I'm going to do that in red. All right, if y is 0, I plug it in. And do you remember what was so nice about this is 2 times 0 is just 0, so 3x minus 0 is 3x. I have 3x equal negative 18, and if I want to find the x, I divide by 3. Oh, x is negative 6. So I have an x-intercept of negative 6, and we write that point as negative 6, 0, and you're expected to write them as points, not just write negative 6 anymore, because it is a point. Now, if I want the y-intercept, I'll do that in blue. If I want the y-intercept, I plug in x equals 0. You always plug in the opposite variable equals 0 to find an intercept, if you remember. So 3x minus 2y is negative 18. Well, if x is 0, that's 0 minus 2y, which is negative 2y, is equal to negative 18. And to get y by itself, you could divide both sides by negative 2. And a negative over a negative is a positive, and it's positive 9. So now I'm just going to sketch something up here really small. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say it's right here. So let's say that's the y-intercept of 9, and what this x-intercept is negative 6. 1, 2, 3, 4, 5, 6 to the left. Maybe right here, and I could sketch it like that, and I didn't even have to solve for y at all. So if you've got something that looks like it's almost or close to standard form, it can be faster to do it this way. So you've got two different methods you could actually use to graph that, and knowing that just gives you more tools to choose from to maybe make you do less work, because if you know all the tools you have to use, sometimes you can do a problem faster. Okay, again, this is going to be kind of hard to do well because I don't have a graph that I can just pop up with this app and put underneath where I'm writing and working, unfortunately. Okay, so for this one, the instructions tell us we're supposed to graph each pair of equations, and but on the same graph basically, and find the coordinates of the point where the graphs intersect. And so we'll find where we think they intersect, and then we will then we're going to prove the point works by plugging in what we think the answer is into both equations and showing that they make true statements. All right, on both of these, if you think about what I said in the last video, on both of these problems, I could solve them for y and graph them that way. Put them in slope-intercept form and graph them. But I'm going to go ahead and do this the way I mentioned secondly, because I think that we can make this easier because of the way they gave us these equations. If 3x plus 2y minus 1 is equal to 0, just add 1 to both sides. I get 3x plus 2y is equal to 1. Now that's standard form, and if you remember, it's easy to graph from standard form if we just get our x-intercept. Remember the x-intercept, we plug in y as 0. And then we need to get our y-intercept, and that would be we plug in x equals 0. And that's really easy to do here, okay? Oh, this is going to be a booger to graph, let me tell you. Okay. Let's see, if I plug in y equals 0, I'll get 3x plus 0 equal 1, because 2 times 0 is 0. So if 3x equal 1, if I divide both sides by 3 to solve for x, I get x is 1/3. Okay. Now that's going to be tough to graph, isn't it? These are going to be very ugly graphs. As a matter of fact, I may just go ahead and upload a piece of graph paper to do this in a minute. So I got 1/3 0. Let me find the y-intercept. I'm still just working on that first equation. I'll do it in green. I'll come down here and work. I'm plugging in x is 0 to find the y-intercept here. So I'm using this as my 0 here. 3x plus 2y equal 1. Well, that's 0. So we get 2y equal 1. 0 plus 2y is 2y. And if I want to solve for y and divide both sides by 2, I get y is 1/2. Okay, so I've got the points 0, 1/2, and 1/3 0. Now, I'm going to have to pull up a piece of graph paper, and even then, it's going to be really, really hard to do these the way they'd ask us to, because these points are not pretty points. They are not going to be whole number points. And it's going to be really hard to tell, I think, maybe where these cross. but I'm going to write them down so that I can do that. Okay, so our second equation, I'll go to a new slide for that. Our second equation was x minus 2y plus 13 equals 0. And again, I could do what I just did a minute ago. I could move the 13 to the other side to put it in standard form if I want to graph really quickly. I get x minus 2y is negative 13. And just like we did with the first one, again, I could solve for y and could graph it that way. So if you like that better, go ahead. I'm just trying to show you how to work maybe faster here. All right, if I want to find the x-intercept, I plug in y is 0. And that's one thing I'm going to do. And then I'll go find the y-intercept. In order to find that, I'll plug in x is 0. Again, we're going to have all these ugly fractions to graph, and that's not the fun part. This would be really easy to graph on your graphing calculator, but if you're going to check it on your graphing calculator, it would have been better if we solved for y. And you know what? Let me do this one a little bit differently. Since I did the first one in standard form, let me kind of backtrack here and solve this one for y and not do this. Let me kind of maybe solve it for y just to demonstrate in case you need help doing that. Plus 2y plus 13 equal to 0. If I want to solve for y, one thing I'm going to do is I'm just going to add my 2y to both sides. It's going to be quicker to do that. So now I have x plus 13 is 2y. Now I don't like looking at it that way, so I'm just going to write it this way. 2y is x plus 13. I'm just going to switch the sides, okay? Now if I want to solve for y, I divide everybody by 2. So I get y equal x over 2. Remember, I can put that 1 in front of that x, and that means my slope is a half. So I'm going to write it as 1/2 x plus 13 over 2. Now, graphing these two equations is going to be fun. Okay, if you think about the first equation we had, I'm going to graph it in blue. I have to do this fast because I'm running out of time on the video. We had the point 0, 1/2, which is right here, and we had the point 1/3, 0, which is right here. Now that's very difficult, isn't it? And so we could try to, and again, this iPad, oh my, that's going to be really hard to do. I knew this isn't going to be easy. Let me try a different color because I've already missed the points. It's just hard to control this stylus here. So I got something like this going on, okay? Now the second thing I had, the second equation was 1/2 x plus 13/2 is equal to y, and so 13 over 2 is like 6.5. Let me graph in green here. 6.5 would be here, and my slope was a half, so it would be up 1 over 2, or it could go down 1 to the right 2, down 1 to the right 2. So let's see, it was here, down 1 to the right 2, to the left 2, down 1 to the left 2, sorry. There's a point, down 1 to the left 2. Okay, so what does it look like they're crossing? Now, I don't know if this is going to be a whole number or not, but I'm going to try to assume that maybe they're trying to be nice. Okay, my graph's really bad. But if you look at where it's close to, it looks like it could be, let me put in yellow where it's close to. This is a whole number answer. I'll go ahead and give you that. This is one of those I'd probably do on my graphing calculator, honestly. But we don't want to be afraid to try stuff like this by hand just because that tells us whether we know it. It looks like it's either going to be like, you know, if you kind of look at my line and my sloppy graphing, one of those yellow dots, it looks like to me it's either going to be -3.5 or -3.6. I happened to check the answer book and it's -3.5. I would never give you one like this and not let you use your calculator. So how do we know if that worked? We're going to say let's try -3.5. Though on my graph it more looks like -3.6, but part of that is I'm graphing with this bulky stylus here, okay? So the equation was 3x, that's what I'm going to do. Okay, I'm running out of video time, so I'm going to talk real fast. What I did is I took the two equations, I plugged in the point